We looked at this example in a previous video where we saw that the limit as x tends to 0 of this expression is negative 215. Let's change it up a bit. Suppose instead of x tending to 0, x tends to infinity. Let's erase what we have here and see what would happen as x tends to infinity. Now, remember, infinity over infinity, the limit doesn't exist. Now, if we look at this, as x gets bigger and bigger, for example, if x reaches 1,000, you'd have 7 times 1,000 square minus 4 over 1,000 plus 30 is equal to 1,000 squared is 1,000,000, and 7 times 1,000,000 is 7,000,000 minus 4 divided by 1,030, right? This would be a large number, large indeed. And as you go on and on, what you would find is that you have 7 times a very big number, minus 4. The 4 has less of an impact as the number gets bigger. When you have 7,000,000 minus 4, it doesn't really affect it that much. So if you ignore the 4 and the 30, you would have infinity. 7 times infinity squared over infinity, because this function is getting larger and larger. So based on what you see so far, it's not working out. The limit doesn't exist. The thing to do is this: anytime you have a function like this, see if you can rewrite it in a way that causes it to work out, right, so that you have a limit. Because maybe the limit exists, it's just the way it is written. So let's see. Suppose you multiply both numerator and denominator by 1 over x squared. Remember, if you multiply both numerator and denominator by 1 over x squared, now, it's just that up here you have 1 over x squared, down here you have 1 over x squared. But guess what? 1 over x squared cancels itself. So it's like multiplying by 1. It's the same value that the expression will have, but it's just that it looks different. So if I rewrite this and say 7x squared minus 4 over x plus 30, and this times 1 over x squared, and this times 1 over x squared, what will happen here is this. This will multiply by 1 over x squared. So that 7x, what am I writing? Let's erase that. You have 7x squared multiplied by 1 over x squared, right? Minus 4, but that is multiplied by 1 over x squared, right? All over, and you're going to have x plus 30, but each of them is multiplied by 1 over x squared. Now, what you're going to have is this: 7x squared over x squared minus 4 over x squared, all divided by x over x squared plus 30 over x squared. You see that? X squared cancel x squared. So you end up with 7 minus 4 over x squared. X over x squared, x will cancel. So it's 1 over x plus 30 over x squared. Alright, so let's work with that. We have found that all of this is the same as 7 minus 4 over x squared divided by 1 over x plus 30 over x squared. You see that? Let's work with that and see what would happen. Let's clean up some part of the board to get some space. Now, what happens in this case? As x tends to infinity, you have 7 minus, it will be 4 over infinity squared. Can you rewrite it as just infinity? A massive number squared under here. A very big massive number squared is just another big massive number. 1 over x. 1 over a very big number plus 30 over a massive number squared. It's just another massive number. Right? Infinity represents a number, well, not really a number, but a value so large, massive amount. It's only in your mind that that number exists. It's so big, massive number. So, what you have is 7 minus 4 over a very big number. It's a small number. 4 over 1,000. If you put 4 over a million, it's very small. Then 4 over a billion is even smaller. And as this number under 4 gets bigger and bigger, the answer approaches 0. So it's 0 divided by 1 over 0. Same thing. 0 plus. You have 30 over infinity. So this approaches 0. Right? Now, as this approaches infinity, you have 7 over 0. That is still infinitely large. Right? Now, if you had divided by x so that you have 1 plus something, if you divide both top and bottom by x, what will happen? What you would have is 7 x squared over x. X squared over x is just x itself. So you have 7 multiplied by x minus 4 over x divided by x over x plus 30 over x. What will happen in that case now? As x tends to infinity, x times 7, that will be infinitely large, minus 4 over a large number is 0, divided by 1 plus 30 over a large number is 0. So it's still infinitely large. Now the problem is that the power of x at the top is larger than the power of x at the bottom. The power of x in the numerator is larger than the power of x in the denominator. So as x tends to infinity, everything gets out of control. It goes to infinity. So the limit in this case does not exist. Right? It does not exist. So I will see you in the next video.